Hello friends, thank you for watching this video. I am Mohamad and I will be showing you today what's new in C# 9 and some of the exciting features that now we got access to. The three topics that we will cover today are top level calls, records, and init setters. Please like and subscribe if you like this video. So what do we need before we get started? So if you're on Windows, what we need is Visual Studio 2019 Community Edition version 16.8.1, or if you're any other environment, what you can do is you can get .NET 5 downloaded and installed with Visual Studio Code. So now let's get started. What we're gonna do first is we're gonna create a console application, and we can add all of these new features and test them out within our console applications. So .NET, we're going to be using the .NET new keyword in order for us to create that application. .NET new console, and we're going to call it sample features. This will take a few seconds. Perfect. Now we have it open. We have created. Now let's open it in our Visual Studio Code. Perfect. So now what we can see is we have a simple application which is empty. All it has is the program.cs file and a simple hello world. Let's open our terminal and let's build this application to make sure everything builds successfully. Perfect. And now if we run it, we should see hello world. Perfect. So the next step after that is we need to make sure that this application is targeting .NET 5. So how do we do that? All we need to do is we can go to sample features and we can check that here the target framework is .NET 5.0, which is perfect. This is what we need. So let's start implementing top level calls. So within our program.cs, let's add another function and let's make it private and static. It's gonna return a string and let's call it get my name. We'll pass it a string name, and all of this function is gonna do is return a string saying hello, pass the name to C# 9 features. Simple message. And now let's call this from our main function. So it's gonna be, let's directly output it. So console dot write line get my name, and we'll pass it my name, Mohamad. Great. So now that we have our function, let's run it to make sure everything is working. So .NET run. Perfect. Hello world and hello Mohamad to C# 9 features. So I forgot the word welcome. Let's run it again and check it. Hello world, hello Mohamad, welcome to C# 9 features. Perfect. So now the application is running, and now we can see that we have a private method that we are calling it from our main method, and everything is within our programming class, and everything is within our namespace, which is a sample feature. That's what we want, and this is what we expect currently from any C# application or any console application that we create. But if we want to make this simpler, and this is one of the new features that's coming in with C# 9, we want to implement something called top level calls. So what is top level calls? So first of all, let's implement them, and then we can go step by step and see how do they work and how do they help us simplify this. So first of all, let us try to remove the namespace and then let's remove the class, and then let's remove the using. Sorry, let's remove the main function, and let's fix this. And since this is gonna be a top level, we don't really need to make it private, or the compiler will start annoying us, refusing to compile. And basically this is it. So what happened here? So top level call basically mean we can strip down all of the namespace, class name, and the introduction function, which is the main function here, and make our program way more simpler and with way less code. So let us first take a look at how many lines our application was before we implemented the top level codes. So in total, for this very simple application, which basically displays two lines of code, 2 lines on the screen, it was around 19 lines, which is a lot, and there's a lot of boilerplate code that, there's a lot of boilerplate code that we don't really need. So right now, if we remove all of this, and we remove these two here, and delete this, and change this, and adjust the spaces a bit, we went down from almost 19 to 9 for this simple application, which is really good. So the benefit of top level calls is for us to simplify our application and make it run in a way better way and way faster way. So we removed some of the boilerplate code that we had, and we simplified our entry points. So how does this work? So currently within our sample application, first let us run it and make sure that everything runs before we delve deep more. So .NET build. Perfect, our application is still building, and now let's run it. .NET run. And we can see that we still have the same output, hello world and hello Mohamad. Okay, I forgot again the welcome. I apologize. And let's run it again. Hello world, hello Mohamad, welcome to C# 9 features. Perfect. So what happened here? So this is one of the new features within C# 9, is the compiler is smart enough to recognize that if we have code on our beginning of the class. So we have a class here which is called program.cs, and if we have, for example, code that's running without any main function and without any namespace and without any class declaration, so when the compiler sees that this code is just pure code and there is no namespace, there's no classes, it will automatically build for us all of those other boilerplate codes and implement our pure code within those. So the compiler in the background will go back to the old feature where it attached the namespace, where it will attach the class, and then it will run the application for us. So this is, for example, a top level code. But within a top level code as well, we cannot, for example, let's create a new class. And we'll call this class, for example, food.cs, which is a simple class. And within this class, for example, let's copy these and let's paste them here, and let's change, for example, hello world to hello world from food, for example. We can see that the compiler is already complaining and it's already given us this red squiggly line that we cannot use this here. And if we look at the error message, it's saying that only one compilation unit can have a top level statement. So why is that? So within our console application, and currently, for example, within our program.cs, we have already added a top level code. So if we create another class and we add top level code to it, the compiler will refuse to do that. So within our console application, we are only allowed to have inside one single class top level code. So you might tell me that, okay, within the program.cs, because it's inside the program.cs, it's accepting it, but not because it's in food.cs. So let's see what happens if I delete program.cs. Let's delete it. And as you can see, as soon as I deleted it, the squiggly line has been removed and the application is also there. So let's try to run this and see if we get the same output. Don't forget that this is not the program.cs, it's food.cs. So .NET build, perfect, it's building, and then .NET run, perfect, we got the same output, hello world from food, and hello Mohamad, welcome to C#9. Perfect. So this is basically what is top level code. It's a simple way for us to directly jump in and create some C# code and create our logic without have to worry about the boilerplate that comes with it. So another point that I would like to mention when it comes to top level code is all of the methods that we're using. So let's create a different methods. And let's call this get my last name, for example. And within this, as you can see, it's a simple function. And let's see, hello, let's put here last name, and let's change just say your last name is. It's a very simple and dumb function, but it will do the job. And let's call this from within here console.writeLine get my last name, and I'll pass my last name, and let's run it and see if it works. Perfect. So hello world from food, hello Mohamad, welcome to C#9 features, and your last name is done. Perfect. So as you can see, we can add as many methods that we want, and we can refer to them, but the methods cannot be public or private. It doesn't take any initializer. So if we put public, the compiler starts to complain that it's not a valid item. Or if we put it private, again same complaint. Even if we put it here private, similar complaint. Or public, any basically access modifier within our top level code is 100% refused by the compiler. Again, we cannot really call a different for example, we cannot do inheritance here and then we can call different classes from within our top level code. This feature might come in the future, but currently we don't have it. So it's a really simple way for us to directly jump into it, and it's to jump into coding and without worrying about any of the boilerplate code. C# will do all of the heavy lifting in creating all of the namespace, in creating the classes, and from there the application will run. So just to summarize, so within the top level code, C# will assume any class that has a top level code as its entry point. It will build it and it will take it from there, and it will run it for us. We cannot have two classes with top level codes in them. It only has to be one, and it doesn't matter which class it is. We cannot have access modifiers to any of our methods, because everything here is basically running in order and everything within a single file, so we don't really have access to our access modifier. And within our top level code, we don't have to really add a class, a namespace. The main idea behind it is for us to simplify as much as possible our code. Another benefit of this is, for example, let's say we are working within our terminal and we have created our file within our terminal. So let's say we created a C# file. So instead of like having to define the namespace and define a class, doing all of this within the terminal and then saving it, make sure everything is in the proper order, and then run it, and then we might have compilation error because of all of that, all of the boilerplate code that we currently have. top level calls will come here and it will facilitate this for us because we don't really need to add all of those. So please, if you have any questions, write them down in the description down below. And now we're gonna jump into our second topic, which is records. So let's jump into records right now. Let's close this application. And from our terminal, let's create our new application. And let's call this, let's first use .NET new keyword, .NET new console. We'll name this record samples. It's gonna take a few seconds. Perfect. And now let's open it in our code editor. So similarly, we have here a program.cs class, which is a very simple program. And let's open our terminal. And let's just run it to make sure that everything is running. So .NET run. Perfect, hello world. And we need to make sure that it's targeting .NET 5.0. So if we click on record sample.cs approach, we can see the target framework is .NET 5.0. Perfect. So what are we gonna do now? First of all, let's define records, and then from there we can create like a sample program, and we can see how records can help us there. So what is record? Records is a new way in C# to define class types, specifically for types that acts as value, not as traditional objects. So traditional objects are a way to encapsulate our classes and objects to hide it from the consumer. And the only way for us to access these information is through methods. So for example, if we change the entire implementation of a class, the user will not be able to know that we changed because they are only getting the information through predefined methods, which is a good implementation. But sometimes this will create an overhead. So when it comes to value style object, is the opposite of this implementation. Their behavior is only defined by their state. So for example, in a JSON call, all of the information that we need is inside that object itself. There is no need for methods to get access to any information. We just need to access that object, its properties. These objects expose by their states. So let's start by creating our application, and we can take it from there. So I'm gonna create a new class. I'm gonna call this class, let's make it a public class. We'll call it person. And this person basically is gonna have two attributes. So let's make them simple. Only it's gonna be first name. Let's make it string as well. Last name, and let's give this person an ID. So 3 attributes. Perfect. So currently we have a simple class which has called person, which has 3 attribute: ID, first name, and last name. So let's create a sample constructor. And call it person, and this constructor is gonna take an int for the ID, a string, and a string for the last name. Okay, and now let's do all of the wiring. ID equal ID, first name equal first name, name, and last name is name. Okay, perfect. Now let's call this class from our side our application. So let's define 3 people. So let's say for person1 equal new person, and let's give it ID 1. Let's give it first name Mohamad and give it last name Lawand. Perfect. So the second person for person 2 equal a new person, ID 2, and let's use Donald Duck, first name Donald and last name Duck. Okay, so now we have two person which we have initialized with two different IDs. Next, let's try right now to serialize these objects. So for JSON P1, because we're going to serializing person 1 equal JSON serializer dot serialize, and we're gonna pass it person 1. Let's fix the references. Perfect. So next what we're gonna do is we're just gonna output this. Don't really need to do that. Let's now serialize reserialize person 1 into an object. So we'll call this person 3, and person 3 should in theory equal 100% equal person 1. So we're gonna put JSON serializer dot deserialize, and we're gonna pass it the person class, and we're gonna pass it a JSON, which is JSON P1. Okay, and then we're gonna do a simple equal operator to check if person 3 and person 1 are the same. So var is equal P3 equal P1 person 1, and let's output the result of that. So console dot write line, let's use string interpolation is person 1 and person 3 equals, and let's do this and put is equal here, and let's close this. And this is what we're gonna do for now, and then we'll delve more deep into it. So what do you think is gonna happen now? So let's first summarize what we did, and then we can delve deep of what do we think is gonna happen before we run it. We have declared a class, it's called person. It takes 3 attributes, ID, first name and last name, and we created a simple constructor, which is normal implementation. And then within our main code, we just defined our first object of person with my name and last name, person 2 with Donald Duck, and then what we did is we serialized. So the command serialize the person 1. So we converted into a string, a JSON, and then what we did is we deserialized. Into an object again, and then we just did a simple equal to see if the person that we just deserialized and the person that we serialized are the same, and then we output it. We don't really need hello world anymore. So let's run the application and see what's the outcome. So the compiler is complaining. Why is it complaining? It's saying that each parameter construct, okay, we didn't create a we should create it by itself, but let's try to do it ctor person and So each parameter constructor void must be behind an object property of field deserialization. Okay, so we just needed an empty constructor for it to automatically build. That's fine. I thought it will create by itself. So once we did that, now we can see that is person 1 and person 3 are equal to false. Although from what we have here, person 1, we just serialize it into that's output.json, so we can see it. So console.writeLine, and we're just gonna use string interpolation, person 1 JSON, and let's use JSON p1. Okay, just to make sure that it's actually getting us the same result. Okay, so let's save this and let's run it again. So we can see person 1 JSON equal ID first name last name. So basically it's serializing correctly, but it's not actually matching it. Why? Because we need to implement another interface which is called the equitable interface, and we need to pass it the person. Now let's implement this. So the first thing is we're gonna implement public override bool equals, so object, and we can just simplify it more by using object is person p and equals p, and then we need to implement public bool equals person. Just note here that we're just writing a lot of code right now just to implement the equitable interface. So other is object, we need to make sure that it is an object, and we need to check now first name and last name are equal. So first name equal other dot first name, and last name equal other dot last name. Okay, and then lastly we need to implement the hash code. So public override and get hash code, sometimes autocomplete is nice, sometimes it's annoying. So hash code dot combine, and we put the first name and put the last name, and let's put the ID as well. Forgot the ID. Okay, and here we forgot also to match the ID, so it has to be ID equal other dot ID, and okay. So basically right now we implemented the equitable interface, and in theory right now once we run this, these two persons should equal. So let's run it again, and it still tells us it's not equal. Okay, let's try it again. So it's still failing. Well, let's change this to this. Instead of direct equal, we'll use the equals, and let's see if this will work. I think this will work. Let's try it again. Perfect. So now our application knows that person 1 and person 3 are the same. But look at all of the boilerplate code that we had to write in order to accomplish this. Okay, another thing, for example, if you wanna, let's do one more thing, which is trying to directly deconstruct. So let's say do var, we'll put here fname, let's put it 3, so id, fname, and lname, and this will equal, for example, from p1. So p1 will be deconstructed into, so person1 will be deconstructed into these, but it's not happy. Why? Because we haven't implemented a deconstructor. So let's implement a deconstructor. So public void deconstruct, okay, and it's gonna turn out, and which is an id, out string fname, and out string and name. Okay, so let's put right now, so id equal id, fname equal first name, and lname equal last name. So now the compiler is happy because we have added the deconstructor. Now let's just output, let's put this for person to change, and let's just output, so console dot write line, let's put string interpolation, we'll put id, and just give it the id, so let's copy this, copy, okay, so first name and last name, so fname and lname. Okay, save, let's put these after the equality, and let's run it and see the output. Perfect. So now we can see that person1, person3 are equal, and then we are able to output it. So for this simple initialization or simple code that we have run here, which is basically just comparing two objects and just outputting or deconstructing an object, look at all of those boilerplate code that we had to run. So we had to create the properties, we had to create a constructor, an empty constructor, then we had to create another constructor to fill in the information, and then we had to implement the equitable interface, then we had to write all of these code in order to adhere to that interface, and then we had to write a deconstructor. So I think this is around from 31 till 67, so that's around 35 lines of code, just boilerplate code that we're gonna add into every class that we create if we want to implement these functions. So how does record solve this problem for us? Or how can records enhance this for us? Well, it's a very easy way. So let's see, let's change this name, for example, to temp person, and in records all we need to do, so let's change this, as well, to temp person. All we need to do in order for us to make this work is just type record person with the parameters, which is going to be int id, string name, first name, and the string last name, and save it. It could be issue with my compiler, so let's just take this and just comment this out instead of just rewrite changing the name of the class. Okay, so let's just comment this out, and let's add our record back. So right now, instead of all of those boilerplate code that we added to add a class, we implemented all of those interfaces and all of those functions with a simple line. So from 36 lines to a single line, we defined a record, a person. Within those person, we defined the attribute, which is ID, first name and last name. And if we look at our code, everything is, the compiler is happy still, but the big test is right now when we want to test it out. So let's test it, and we can see everything still work. Our person is deserialized correctly, person 1 and person 3 are equal, and we are able to directly deconstruct our record. So what are records? So records basically are immutable objects that we use in order for us to transfer data from one place to another. Or maybe that's the wrong word, but it's not transferring data, it's actually transferring the state of an object from one place to another. Because basically right now the class person that we currently have, we're only using it for its state and for the data that relies within it. We're not really using it for anything else. So for this reason, record were introduced instead of having them all of the boilerplate code in order for us to accomplish that reason, to accomplish the data manipulation or data checks. We can do those with records. So just to reiterate, value styles object is what records are. So basically, let's think of person like a JSON class, or it's something like a DTO. We don't really need to have all of these boilerplate code in order for us to implement this functionality. What we can do is we can just simply utilize the records feature and to do all of the data management that we want. Another thing that I would like to mention about records is when we add a record, we convert the boilerplate into a single line. So basically, first we have much more cleaner code, and it's way more easier to manage, and it's less error prone. So let's say on the long run, let's call this record person 2 person test, for example, just for now, and let's uncomment this. And let's say in the future I decided that I want to add another attribute string, and I'm gonna call it email. So right now, if I want to run this is gonna fail because I didn't implement the deconstructor to get at the email. I didn't add it to the equitable interface to check it. So all of the works that I need to do, basically, it's gonna anything that I need to do all of the underlying wiring so it will work again, and this is error prone. But if, for example, I want to add this feature to my record, let's comment this out again, and let's name it back to person. All I need to do is add a new field, string email, and everything else that I want, it should be there. Why is it not happy? Because I need to define it. So here I can put email. So my email is, for example, am@am.com. To let's see, Donald at Disney at, let's say, at am.com, and here we need to add it to the deconstructor, so I'll put email, and it worked. It also even gave me the ability to update anywhere that this record has been used in order to accommodate, because this record, as we have mentioned, are immutable. So the immutability aspects of record in C# is by default. So C# by default is a mutable language where there is a certain construct where we can opt in to immutability. Like if, for example, we're using read-only structs or read-only fields. But this immutability comes with a cost. So we need to make sure that they are immutable. Let's create a new class, and then we can explain how records help us with immutability. So let's create a class called public class, we'll call it point, and this class is gonna be very simple, or it's gonna have an int which is the x point, and another one which is gonna be the y. Very simple and straight to the point. And within this class, all we're gonna do is we're just gonna create a constructor for it. So or point, and we're gonna put int x and int y. Very simple, and we're just gonna do the pipeline. Perfect. And now we have a simple class point which is defining an x and a y. So this class is immutable. What are we gonna do if we wanna make it immutable? So what we can do, so for example, what we can do is we can make the set a private set. First, before we do any of this, let's declare an object of this class, and we can take it from there. So after this, let's put point class for mutability, so we know where we stand. So let's var p1 equal new point, and let's put the coordinates 3, 3, 4, 3, 5, 3, 6. Okay, that's fine. So now what you can see here is we have defined a point and we have initialized it through the constructor, which is fine. Or what we can do as well, we can do, for example, var p2 equal new point, and then we put p2.x equal, for example, 3, let's put it 5, and p2.y equal, for example, 8. So let's create a default constructor. And we can define it this way, which is also fine. But what happens if we want to make this class immutable? So we have two ways to do that. So let's do this as a private set, and again here private set. And as you can see, as soon as we did this a private set, the compiler is not happy anymore, because it's telling us that we cannot directly access these fields in order for us to set it. So this is failing. And if we remove this, let's keep this for now. So this is failing and it's not happy about it. Let's comment it out. Let's comment it out. So this is a good implementation if we're gonna make it immutable. But there's also different ways if we're gonna do this, for example. So we can directly remove this. And let's run this. And it will still work, because we only having a public getters for it, we're not having a setters for it. But this is a lot of code in order for us to have an immutable object, and we have to basically define the constructors and work from there. How does records help us with that? So simply with records, if for example we wanna, let's change this one from point, I will create a new record. So we'll put record, we'll put point, and it's gonna take int x and int y. Simple as that. And let's comment this out. So right now, oh sorry, I had a typo here. Okay, so right now this still works, and this will not work by out of the box. This will not work because we cannot the object the type record here is immutable, and we cannot really access it. So how do we actually wanna, if you wanna, for example, update the value of p1 or the value of p1 so it will have a new value, new values, How do we do that? Because this record is immutable. So it's very simple. What we need to do is we need to make a copy of it and then change the state and then put it back in. So what do I mean by that? So we're gonna put, for example, p1 equal p1, and then we're gonna put width, and we're gonna put x equal, for example, 6. 6, and then we'll close it. So basically here, because this record is immutable and we cannot really change it past the point of initialization, what we're doing here is we're creating a new record, and we're updating the data of it, the variables of it, and then we're passing it back into p1. So we're not changing the actual value of p1, we're basically creating an object of p1 and a record of p1 and then putting it back in. Let's say, okay, I like immutability, but I don't really, it's not for me, and I don't really want to implement it, but I really like the record functionality. How can I do that? It's very simple as well. So in case I want to change the record from being immutable to mutable, all of the changes that I need to do is I need to remove this semicolon, and basically similar to a constructor. So no, this is the person. Where's the record? Where's the points one here? So let's delete this, and it's gonna be as simple as int we'll call it x get and set, and all it equal x, and prop int y, and this is gonna equal y. So within this implementation here, what did we do? We override the implementation of a record to make its parameters immutable to mutable. So right now what we can do is, let's go back here, and let's say instead of this I want to update the x to be 6. All I need to do is p1 dot x equals 6, and this will work because I have enforced mutability to my record, and now we can see the compiler is not complaining. But in case I only implement it on the y, for example, only not the x, the compiler complained because this is a mutable record and I cannot change it. So I hope this makes sense. I hope you can see the powerful features of the records. I think records are still in infancy. There's a lot of work, a lot of exploration that needs to be done on how we can utilize them at its best. And I think a really good implementation of record, if for example we're using it in order when it comes to JSON file, because if we're using a lot of DTOs when it comes to APIs, all of those classes that we're currently creating in order for us to accommodate, for example, to the iEquitable interface or any of the other interface that we use in order to make sure that the objects matching or the actual objects are being utilized. All of this boilerplate code can be just removed. Let's say we have 10 DTOs. Instead of having 10 files with 10 implementations, all we need to have is a single files with 10 lines, which is every line is a record to represent those DTOs. Please feel free to ask any questions in the comments down below. If you have any questions or if you have anything which is not clear, please let me know as well. So the final point that we're going to be covering today are init setters. So again, we're going back to the point of classes and initialization. So let's create a new class, and this new class we're gonna call it car. So public class car, and this class, it's gonna have two properties. We're gonna put one string, which is the brand, and we're gonna put another string, which is gonna be let's create a new solution, better and cleaner. Okay, let's save this, let's close, and let's add a new one, which is gonna be .NET new console We'll give it a name, init sample, and that's it. Let's run it. Perfect, it's building. Now let's open it. Okay, perfect. So within our program.cs, let's create a new class. So public class, and we'll call it car. And as we said before, we're gonna have two properties. We're gonna be a string, which is gonna be the brand, and we're gonna have another string, which is gonna be the color. Prop string, and it's gonna be the color. So let's initialize, an object. So far, we'll call it C1 equal a new car. New car. If I can type. Now let's use the class car that we have. So C1 equal car, and let's put C1 dot brand, for example, equal let's say Mercedes, and let's say C1 dot color black, which is the best color for a car. And anything else? Okay, let's create another class, which is another object, sorry. So far, C2 equal a new car, and C2 sorry dot brand. Let's put also, let's see, say this is a very complicated choosing a car. Let's choose BMW, and C2 dot color, we'll put it in hideous white. Anyways, so now we have two objects, which is gonna be car1 and car2. The thing is, if let's say I wanna then update car1 to change the color, for example, so C1 dot color, if I wanna, for example, make it gray, I can do this right now, and we can see that I have the ability to get and set basically the information that I want after the object has been created. So within the first line, I'm creating an object, then I'm setting all of the information that I want with it, and then afterwards I can re-update it, this is really good. But let's say I want to make it immutable, and I only want my car to be, or my information to be defined on the startup of the class. So how can I do that? This is let's say this is prior to C#9. What we need to do is we need to create a constructor. We'll name this is car, and the parameter is gonna be, let's say, brand string brand, and the string color, and then from here we need to put brand equal brand and color equal color, and I need to make this a private set. So right now this will not work. We can see the compiler is complaining because we made this object immutable and we cannot really access its properties anymore. So let's comment these out, and let's make them from here. So as we said, it's Mercedes and it's black, and here we have a BMW and we have a white car. And now with the compiler is happy, again we are able to utilize and initialize our objects. So let's just output these out. So put console.writeLine, and let's use string interpolation. We'd say brand, it's gonna be for the first car, so C1.brand, and color. C1.color, and since I'm lazy, we'll just duplicate this, and instead of C1 it's gonna be C2. And let's run this application. So let's open our terminal and just type .NET run. This should take like a few seconds, and now we can see brand, which is Mercedes, color black, and brand BMW color white. And you can see we are still able to access the getter, but we are not able to access the setter. Let's say I want to change the color of my car. So let's say I want to make it, for example, red. So C1.color would say equal red. So as you can see, the compiler is complaining because this is an immutable object and it's inaccessible for us. So we cannot do this, which is the right implementation that we want. But what happens if, let's say I want, instead of having all of this code, for example, to create a constructor in order for us to initialize it, if I want to use this type of implementation, which is C1.brand equal XYZ and C1.color, in order for me to initialize the object, but only on initialization. So down the road, so after initialize, it cannot be changed. So C#9 will help us with that. Instead of having this, what we can do is we can just change it to init and change this to init. And let's comment out this because we don't really need it. And we don't really need this. And we don't really need this. And let's uncomment these. And let's uncomment this. Oh, the reason why it's complaining, okay, excuse me, it's still early morning. Well, if we do it like this, so brand equal Mercedes, and what was the other one, color equal black. So what did we do here? So instead of having it like instead of having a constructor initialization, what we did is we declared the object and then we initialized it, and then from here we are not able to change it anymore. So let's do the same first. Let's do the same thing for BMW. So it's going to be something like this, and then we can take these, put them here, remove this, and replace this with a comma, and delete this. Okay, so right now let's say I want to change the color to C1 to gray. It still doesn't work because this is an immutable object, because within our class initialization we only said that it's we are allowed to change it within the initialization phase. So we can only set it when we initialize it. We cannot really set it when we wanna use it anyway anywhere else within our code. So this is like a nice trick within C#9 to keep our code compact, and it's a very powerful utility and for us to keep immutability within our code. So thank you very much for watching. I hope you really enjoyed this video and it was beneficial for you to see some of the power that C#9 brings us. Please write down any question in the comments down below, and thank you again for watching. Please like, share and subscribe. It will really help the channel. Have a good day.